At the end of this lecture, you should understand clearly the core principle behind autoencoders. You should know what an encoding is. Autoencoders are neural networks which are capable of learning efficient representations of the input data. These efficient representations tend to be of a low dimensionality and are typically called codings. Autoencoders are a kind of unsupervised learning technique. Because autoencoder representations have lower dimensionality, they're great for feature detection or latent factor analysis. Find the most important factors which drive the underlying data. In order to understand how autoencoders work to generate these efficient representations, you have to understand what an encoding is. Let's say you were to go about this task of memorizing a sequence of numbers, and the sequence that you have to memorize is the one that you see on screen. It isn't a very large sequence. There are only about 8 numbers in there. You could say, yeah, sure, I could memorize it. But what if I were to ask you to memorize this even larger sequence? Now, at first glance, you'd say it's more difficult to memorize the larger sequence as compared with the smaller ones. Once you observe the two sequences closely, though, you'll find out that the second one has some underlying pattern. The first one, the numbers have been generated completely at random. Only brute force memorization will work with this one. And as the sequences get longer, that is obviously extremely difficult. It's already difficult with this sequence of 8 numbers. But the sequence below, which is a much longer sequence, has some underlying pattern which has generated these numbers in this order. If you notice carefully that if you start off with an even number, the number which comes after that simply divides the previous number by 2. 50 divided by 2 is equal to 25. On the other hand, if you have an odd number, the number which comes after that multiplies the number by 3 and adds a 1. Now, the sequence has been generated using these two rules. So you can represent the entire sequence using these two rules, which is a more compact representation. These rules form the encoding of the sequence. This happens to be a very famous sequence called the hailstone sequence. You can stretch the sequence all the way to infinity. You can extrapolate it to any number that you want, but using this encoding, you'll always be able to remember this long sequence. And this is how autoencoders work. The underlying principle behind autoencoders is that they try to find patterns in data so that it can remember the data using a much more compact representation. This compact representation is called an encoding. The objective of autoencoders is to find the encodings in the underlying data. An encoding can be thought of some pattern in the underlying data which allows you to represent the data with low dimensionality. An encoding captures the essence of the data in a compact form.